This is a tutorial video about problem 11 and problem 12 from homework set 6 about solutions and concentration. You may notice that your ionic compound, your mass, and your volume for this problem are different than the ones in the video, but the problem-solving strategies will be the same. All right, our problem says determine the concentrations of magnesium chloride, magnesium 2+ cation, and chloride anion in a solution prepared by dissolving 1.75 times 10 to the negative 4th grams of magnesium chloride and 1.50 liters of water. Express all three concentrations in molarity. Additionally, express the concentrations of the ionic species in parts per million. There's a lot of parts here, 5 different answers, but we'll start from the beginning. So we have a mass and we have a volume. Specifically, this is the volume for the solution, and this is the mass of the solute. Magnesium chloride is the thing being dissolved in water. We need to find molarity for each of these pieces. So what we have is we have grams over liters, and what we need to get to is molarity, which is moles per liter, specifically moles of solute per liter of solution, and grams of solute per liters of solution. Starts to get complicated, so we don't want to be sloppy. So our denominator, the liters of solution, that's fine. We don't need to make any changes to that. It is the top, the numerator, that needs to be changed. We need to move between grams and moles, and we use the molar mass to move between grams and moles. That's our plan. Okay, so we've got 1.75 times 10 to the negative 4th grams of magnesium chloride over 1.50 liters of solution. And in this case, I think it actually did say 1.50 liters of water, which is the solvent, but the assumption here is that the mass of the solute is so small that the total volume is approximately the same. Okay, so mass over volume, and then we need to use the molar mass to convert from grams into moles. And molar mass is grams per mole, and I need grams to cancel, so I want grams of magnesium chloride on the bottom and moles of magnesium chloride on the top. So grams magnesium chloride and grams magnesium chloride cancel, and now we have moles magnesium chloride per liters of solution. So the units are good. We need to do our molar mass calculation quickly first. So magnesium right here, molar mass 24.305. And we need 2 times chlorine, which is here, 35.453. Okay, looks like our molar mass is 95.211 grams per mole. And so now we're ready to do our calculation. We've got too many things on the screen. That's what we've got. 1.75 exponent -4 for the mass, divided by 1.50 for the volume, and divided by 95.211 for the molar mass. That gives us 1.225 times 10 to the -6th moles per liter magnesium chloride. Cool. But it didn't just ask for one concentration, it asked for all three concentrations. So we need not just the ionic compound itself, but the concentration of the cation and the concentration of just the anion. And this is a little tricky. This is a kind of problem-solving process we haven't thought about before, but I know that you guys can answer it because I know that you understand how ionic compounds work. So in magnesium chloride, we know that for every 1 magnesium chloride, there is 1 magnesium 2 plus. And we know that for every 1 magnesium chloride, there are 2 chloride minuses, because that's what those subscripts mean in the compound. So when we need to find the concentration of each of the ions, we can simply take the concentration we have and we can multiply it by these conversion factors. So we can say 1.225 times 10 to the negative 6th molar magnesium chloride. We can multiply that by 1 magnesium over 1 magnesium chloride. We can do the same for chlorine. 2 molarity of chlorine over 1 molarity magnesium chloride. So this one is just going to give me the same number because I'm multiplying by 1. 1.225 times 10 to the negative 6th molarity of magnesium. And this one is going to be my answer multiplied by 2. 2.451 times 10 to the negative 6th molar of chloride. Remember to just multiply your original number by 2 on the calculator and not to multiply your rounded number, because if I multiplied that rounded number, I would end up with 2.450 instead of 2.451. Remember not to round until the very end. Okay, so we've got 1, 2, 3 molarities, and now we need to express the concentrations of the ionic species in ppm. So ionic species, that's these two. These are the ions in solution. So we need to convert them from molarity to parts per million. I don't know if we're going to fit it on the page, but we'll make an effort. So molarity is in moles of solute per liters of solution. And parts per million is a mass measurement. So that's going to be in grams of solute per grams of solution. And then we'll multiply that by 1 million to give parts per million. So it looks like we're going to need to convert both sides here. We need to go from moles back to grams using our molar mass, and from liters to grams using density. Whenever we convert between volume and mass, we use the density of the solution. Okay, so 2 of these numbers are the same and 1 of these numbers is different. So let's start with the first number, 1.225 times 10 to the negative 6th moles of magnesium chloride, or just magnesium. Actually, no, we only need these 2, right? Just magnesium then. Moles of magnesium over 1 liter of solution. Okay, let's do the numerator first. So we have moles of magnesium and we need to get to grams of magnesium. So let's be careful here. Because we're just working with magnesium and not magnesium chloride, we just need the molar mass of magnesium, the element, which we had up here. That's 24.3 grams of magnesium and 1 mole of elemental magnesium. And then density, I don't think was included, which wasn't very kind of you, but density of water for things that are mostly water is 1 gram per milliliter. So let's convert from liters to milliliters. And then we'll use the density of water to convert to mass. And we will multiply by 10 to the 6th. Okay. What do we got? So here's my answer for before. I'm going to store that as x so I can use it. So we've got x times 24.3050 divided by 1,000 times 10 to the 6th. And we have 0.02978. And our unit is going to be parts per million of magnesium. Cool. And then let's do it again, but we'll cheat and we'll save ourselves some work. So we're going to replace this number with the molarity for the chloride when we do it again, and we're going to replace the molar mass with the molar mass of a single chlorine, which was 35. And the other parts will be the same. The liters to milliliters will be the same, and the density of the solution will be the same. Okay. So 2 times x, that's our number, our molarity we're starting with. That number times 35.453 divided by 1,000 times 10 to the 6th. That gives me 0.08688 parts per million. Okay, we got a little messy in the middle, but we made it. So basically we took the mass and the volume, and we found the molarity using the molar mass. Then we took what we knew about the number of ions of the cation and the anion in each formula unit, and we used that to find the molarity of each of the ions. Then we converted from molarity to parts per million using the molar mass of each of the different elements by itself and the density of the solution, which is 1 gram per milliliter for water. Intense problem indeed. Okay, so that's problem number 11. And while we're here, we will do problem number 12 from homework 6 as well. You may notice that you have a different mass percent and a different density, but the other steps for problem solving will remain the same. Okay, so this problem says the mass percent of hydrochloric acid within a solution is 40.00%. Given that the density of this solution is 1.200 grams per milliliter, find the molarity of the solution. So again, we have 1 unit of concentration, and we are trying to find another unit of concentration, and we've been given the density, and we may or may not need the molar mass as our tools. Okay, so we have mass percent. Mass percent is mass of the solute over mass of the solution. That's what we have, and we need to find molarity, which is moles of the solute over liters of the solution. So both the numerator and the denominator are going to need to change. For our numerator, we need to get from grams to moles, and we can use our molar mass. For our denominator, we need to get from grams to liters, so we're going to need to use density. Okay, there's our plan. So now for our math. So we have 40.00 mass percent, which is 40 grams of hydrochloric acid per 100 grams of solution. And I believe this is a solution in water. So then we need to use the molar mass of HCl to convert from grams to moles. So we will need the moles on the top and the grams on the bottom. We'll come back to that. And then for our denominator, we need to convert from grams to liters of solution using the density. So our density was given 0.200 grams of solution per 1 milliliter of solution. And then we want our final unit to be in liters instead of milliliters. Okay, so we have moles over liters. We need the molar mass. Okay. So we need hydrogen, 1.008, plus chlorine, which I think we just did, 35.453. Whoops. Okay, 36.461 grams per mole is our molar mass. We'll plug that in. Okay, so we've got 40 over 100. That's our mass percent for HCl. We're going to divide by our molar mass of 36.461. We're going to multiply by the solution density of 1.200, and then we're going to multiply by 1,000. So that gives me 13.16 molar HCl. And we can represent that by writing the name of the compound inside of brackets. Let's see, is that the whole problem? Gosh, that seems so short in comparison to the last one. Okay, so again, when we have two different concentration units, we need to figure out what sort of transformation to do with the numerator and what sort of transformation to do with the denominator. We just need to make sure that we're setting up the equation not just with the grams and the moles and the milliliters, but also with the name of the compound. Because if I multiplied this upside down, if I used this grams to cancel out this grams of solution, I would end up with this fraction upside down, and I'd end up with a completely different number. So you not only have to cancel the grams, you also have to cancel the name of the compound. Hope this was useful, and good luck finishing your homework.